Welcome back to our discussion about the graphs of polynomial functions and especially the attributes of the graphs of polynomial functions. And in this video, we are going to talk about finding zeros and their multiplicities. So let's take a look at what that is. What is a multiplicity of a zero? Well, that's nothing more than the power of its factor. So consider this polynomial. F of x is equal to 5 times 4x minus 1 to the third power times x plus 7 to the second power, or x plus 7 squared. We could actually write this out like this, right? 4x minus 1 to the third power is the same as 4x minus 1 times 4x minus 1 times 4x minus 1. And x plus 7 squared is x plus 7 times x plus 7. What that means is, the factor 4x minus 1 is multiplied 3 times here. And the corresponding zero that comes with that factor is 1/4. We get that by setting that factor equal to 0 and solving. So the multiplicity of 1/4 is 3 because that factor occurs 3 times. Okay. Same over here, the factor x plus 7 is multiplied 2 times. And the corresponding zero here is -7. So that means that the multiplicity of -7 is 2. Now, why is that important? Well, it turns out that with all polynomial functions, if the multiplicity of a zero is even, then the graph will actually bounce off the x-axis at that zero. Instead of crossing through it, it's just going to bounce. If it's coming up from the top, it's going to bounce and go back up. If it's coming from the bottom, it's going to bounce and go back down. And if the multiplicity is odd, well then the graph crosses the x-axis at that zero. So that's the value of knowing what multiplicities are. So let's give it a shot. Let's do some examples here. I've got 3 functions here. For each of these functions, we are to find and interpret the multiplicities of the zeros of the functions. Okay, so let's start with this first function. F of x is equal to 3 times x minus 5 squared times x plus 4 to the 5th. We have 1, 2, 3 factors, but this factor here in front does not have an x, and so this is not going to represent a zero at all. But this factor here, if I set this factor equal to 0 and solve for x, we would get a zero of 5. And then we can say that the multiplicity of this zero, well, that is 2. Okay, that's the power of that factor. And what does it mean if it has a multiplicity of 2? Well, it's an even multiplicity, which means it's going to bounce on the x-axis. So the graph will bounce off the x-axis at x equals 5. Okay, so bouncing because it's even and at this particular zero. Okay, let's try the other zero from this function. The other zero here is -4. We find this other zero by setting that factor equal to 0, and we get that zero is -4. The multiplicity is 5, which means the graph will cross the x-axis at the... Let's look at this next function. Here we have f of x is equal to half x times x plus 2/3 raised to the 31st power times x minus 4 to the 52nd power. Okay, and so I know this is a little outlandish, but bear with me, okay? First, we need to recognize that this is a factor that's going to generate a zero. We have a variable here, so we set this equal to 0, and we say half x equals 0. That means x equals 0 is a 0. Okay, and what's the multiplicity? Well, what's the power right there? What's the power on x? That's going to be 1. Which means we have the graph crossing the x-axis at x equals 0. Factor, we'll take this factor x plus 2/3 and set it equal to 0, and we'll get a zero that is -2/3. X is equal to -2/3. And we know that the multiplicity here is 31, which is an odd number, which means that the graph is going to cross the x-axis at x equals negative 2/3. The last factor for this function, x minus 4, if we set it equal to 0, we'll get a 0 of x equals 4. It's going to have a multiplicity of 52, which is an even number. And that means that the graph will bounce off the x-axis at x equals 4. The last example here we have is a little bit different. Now, what makes it different from the previous two examples? If you look at the first two functions that we discussed, they're in factored form. Each of these pieces are factors, okay? And if we're looking at this last example, this is in expanded form where all the factors have been multiplied out. But that makes it more difficult to see the zeros when we can't see the factors. So the first thing we will want to do is factor this function. And we will see that it can be factored by grouping, and you will get the function is equal to x plus 3 times x minus 3 times x plus 5. Now, once it's in this factored form, it's really very easy for us to find the zeros. Setting each of those factors equal to 0 will get our 0. So x is equal to negative 3 is our first 0. The multiplicity there is 1. It's raised to the first power, even though we can't see that 1. And the interpretation is that the graph will cross the x-axis there at x equals negative 3. The next factor, the factor right in the middle, will give us a 0 of x equals 3. The multiplicity is again 1, which means the graph will cross the x-axis there at x equals 3. And last, we have a 0 of negative 5. The multiplicity being 1 more time, and the graph will be crossing the x-axis at x equals negative 5. All right, that wraps up our discussion about multiplicities of zeros. The next video we will talk about maximum turning points in the graphs of polynomial functions. I'll see you then.